Welcome to Mrs. Mahoney's podcast. This is our third one in our Unit 3 on Unit 11 on acids and bases. And we are at the top of page 9, and we're going to talk about what happens when we mix an acid with a base. Okay, now one thing, I know we've looked at Bronsted-Lowry's and they look kind of similar as far as, that's Panda, which I will be showing you a picture at the end of the podcast, so stay tuned. Anyway, back to this. We have an acid and a base. This isn't looking at the Bronsted-Lowry when we did acid-base, conjugate acid, conjugate base. This is totally different. How do I know? This is a single arrow. This is going to a reaction. This is called a neutralization reaction. So and these are the ones typically what we're going to see, not always, the majority we're going to see is with a strong acid and a strong base. So what happens if I take this acid and a water, this goes back to, remember we listed this as properties, what do I get? A salt and the water. How does that happen? So let's look at this example. Here's my acid, acetic acid. So here's the hydrogen and the acetate. And then what do I have? Sodium hydroxide. So here I get the strong, but some vinegar, acetic acid is actually a weak acid. So we'll be seeing weaks also. So what happens? It's just a double replacement. So remember, if we do just like a double replacement, borrow Mrs. Fisher's rainbow, remember the positive is going to go with this negative. This positive is going to go with this negative. Remembering that we still always write our positives first. So what do we have? Sodium acetate, which is soluble in water. And then we have H plus OH. HOH. What's a more common way of writing HOH? You know it as H2O. Okay, now look at water's a liquid. It's not aqueous because it's not water dissolved in water. Water itself is a molecule, so that's why the water is a liquid. And that's going to make a difference down here. That's it. That's all it is. A neutralization reaction is just another specific type of a double replacement reaction. We have precipitation reactions that make a solid. Neutralization reactions make a water. And so look at why the name. This pH would have more of an acidic pH. This would have a basic pH. What happens? Then they come together and it's going to make a neutral, hence water reaction. When we do titrations, we'll talk a little bit about titration curves and does it really always end at pH of 7? And so we'll talk a little bit about that when we actually look at the titrations. And that's the lab that's part of this. We're actually going to do these reactions. They're really good for actually figuring out the concentrations of each of these. So let's just write some. So this is where it's the easy part. What do I always know I'm going to get out of it? Well, first thing I always know, I'm getting water. Where does the water come from? HOH. Now remember that 2 doesn't matter. The 2 is for the OH because that's what it needs for the calcium. We still have to make the right compounds. Calcium is a +2, chloride a -1. So when I write my formula for calcium chloride, which is aqueous, that's why I have the 2. Then go back and balance it. So I need the 2 chlorines. And so how many total hydrogens? I have 2 plus 2, 4 hydrogens is why I'll need to put the 2 in front of my waters. Okay, sulfuric acid, lithium hydroxide. What do I get out of it? H2O. Okay, so what salt am I making out of this one? I have lithium sulfate. And again, I go back as a balanced? No, because of the lithium. So then what do I have? 2, 4 hydrogens. I'll have my 2 there. Okay, what do I have here? Just more really formula writing. So what do I have? Magnesium hydroxide. And this tends to be more of a solid because of the solubility rules. We can mix a solid acid with it. If we have time after the EOC, there's a few labs I'd like to do. One of them is you're going to have to figure out what an unknown acid is, and they're actually solids, by doing a titration. So what do I know I get? Okay, we can get this. I can get one product. If you miss this, getting one product by an acid base, I don't know what to say. You always know that you're going to get water out of it. You always get water. You always get water. So what else do I have? Magnesium nitrate. Magnesium is a +2. Nitrate is a -1. I'm probably running out of room there. Aqueous. Again, we need to make sure it's balanced. 2 nitrates, 2 in the water. So down here you have the chloric acid on number 4. You guessed it. I want you to do that one. Look up your formulas. Make sure your formula for chloric acid. Don't forget to balance it and do the states. Okay, I want to look down here then at this net ionic. They haven't gone away. We can write a net ionic for this. It's the same concept, nothing's changed. So I figured if we do it again, keep doing it, maybe it will click. Sometimes we have to see it in multiple times for it to click. But it's the first thing, still a balanced equation. So what? Hydrobromic acid. Oh, and I wanted to change this because I don't want to do the magnesium hydroxide. Let's go ahead and do it with a strong base. So let's change it to, what did I change it to? If I can spell, strontium hydroxide and K instead. Let's go ahead and do it with a strong base. So what do I have? Write the balanced equation first. So I have hydrobromic acid, and it's going to be mixed with strontium hydroxide. Okay, assuming that's aqueous too. What do I get out of it? Let's see. Oh yeah, water and strontium bromide, which is aqueous. Okay, still go back and balance. Nothing new here. Balance. Okay, nothing has changed. Remember, separate aqueous, separate aqueous, separate aqueous. Okay, so what do I have? Aqueous. 2 hydrogen ions. What's important at this stage? States and charges has not changed. So break it apart. If it's aqueous, break it apart. This is aqueous. What do? Break it apart. And I make sure I put my states. And look at here, I have 2 hydroxides. That's why I say 2 hydroxides. I don't know why my pen is disappearing. Okay, here, look at right here. Remember, we said solid, liquid, gases keep together. Only separate aqueous, only separate aqueous, only separate aqueous. So what do? It's a liquid, keep it together. Keep liquids together. It's aqueous, separate aqueous, strontium plus 2, and there's the 2 bromides. Okay, net ionics. Now we can look at it, what's crossing out. I still sometimes think it's easier on a net ionic to actually start at the end. What am I making? What did not separate? What is really happening? Water was made. How did this water get made? Well, if you look at, you do have bromines on both sides, bromides, excuse me, and strontiums on both sides, so they're going to be canceling. So what is left? How did this water get formed? When 2 hydrogens and the hydroxides. Now we could drop the 2's if you want, because the 2's would cancel out. I'm just carrying them on down. But look at, this is what's happening. This again, let's get out the garbage and look at what's happening. Okay, and then let's go ahead and write the spectators. So what's happening in there? Hydrogen ions reacting with the hydroxide to make the water. That's what drives, that's what gets this neutralization reaction to happen. So what is not involved, what are just floating around in the water watching? Bromide ions weren't involved, and the strontium ions were not involved. Notice I have charges on everything, states, all those little details need to be on there. I would expect that this is going to show up on a test again. It gives you another opportunity. It should be an easy one. If not, you need to come in to figure out how to make it that easy one. So we'll be practicing these on Tuesday, because we don't have school on Monday, and we'll probably pull up some more pHs and just practice on that, because pHs will be on the quiz that you're going to take on Wednesday. Before we go, promise you I'll show you a picture. So here's Panda. See if I can actually get it to where you can make sure you can see it. even she's studying and helping prepare. So in our family, we're a pretty studious family. So even the dog gets involved and has to do her studying. So I hope you have a great 3 days, and I will see you on Tuesday.